Welcome to the new module, Plants in Permaculture. Module Learning Outcomes. After completing this module, you should be able to understand and apply the 12 principles of permaculture, compare and contrast monoculture and polyculture agricultural practices, explain the mechanism of nitrogen fixation and its role within the nitrogen cycle, describe different types of intercropping methods and explain their pros and cons, explain and use the concept of alley cropping, companion planting, and crop rotation in the context of a permaculture farm. Describe the layers of a permaculture plant guild and explain their importance in establishing and maintaining a permaculture farm. Understand the differences in permaculture system for wet, dry, and temperate climates. Appreciate the importance of seed banks in conserving plant genetic diversity. The 12 principles of permaculture. The term permaculture was coined by Bill Mollison for established farming practices by the natives of the land. This traditional knowledge of native civilizations is now being revived with new ideas and is becoming new revolution for sustainable farming practices. In some part of the world, people are still practicing this sustainable method of farming without any knowledge of the term permaculture. The Australian designer David Holmgren has set these 12 principles of permaculture. Creatively use and respond to change. This principle recognizes that changes to climate and ecosystem are inevitable and would need to be addressed. It proposes creation of an ecosystem of perennial plants as opposed to cultivated ecosystem based on annual crops. Such a system is proven to be more balanced and resilient to seasonal variabilities. Observe and interact. This principle is about observing traditional knowledge and practices and sharing them with the world to ensure a sustainable future. Catch and store energy. This principle recognizes unequal distribution of resources in a given year and suggests that resources such as water be conserved when they are available in plenty so that they are available throughout the year. For example, water conservation was practiced by people that inhabited the wet regions of the Mayan civilization, arid regions of the Persian civilization, and dry regions of the Indus Valley civilization. Canal systems and catchment methods were used to store rainwater, which was used for irrigation and personal consumption during dry spells. This principle encourages us to revive and use such traditional methods in permaculture practices. Obtain a yield. This principle points out that at the end of the day, the output from a permaculture farm should be in sufficient quantities so as to provide sustenance to the community. Self-regulate, accept feedback. This principle recommends that we constantly observe how plants are faring on a permaculture farm and accept that knowledge to modify our farming practices to make them more self-sustaining. Use and value renewable. Renewable energy such as solar, wind, and hydro should be incorporated in permaculture in order to reduce our reliance on non-renewable energy sources. This is a natural step towards achieving sustainability. Produce no waste. This principle recommends not letting anything go to waste on a permaculture farm. For example, composting should be used to turn farm waste, kitchen waste, and garden waste into organic and nutrient rich fertilizers. Similarly, grey water from kitchen, washing, etc., can be used for irrigation. Design from patterns to detail. This principle is all about designing various components of a permaculture farm that are in sync with the nature. Locations for components such as fruit orchard, vegetable garden, crops, pasture for farm animals, etc., should be selected on the basis of solar, wind, and rainfall patterns as well as topography on your permaculture farm. Integrate. This principle recommends taking advantage of natural symbiosis that exists between different plant species or between plants and organisms or between plants and animals so as to achieve mutually supportive integration of these components. Other practices such as bee farming or poultry or fish farming should be integrated into permaculture to take advantage of their beneficial effects. Use small, slow solution. This principle reinforces the underlying objective of a permaculture farm, which is to move away from intensive industrial agriculture practices that are proven to be damaging to the environment and are unsustainable. We should recognize that sustainable farming requires time. Most processes are inherently slow because they need to be sustainable. However, they become more efficient with time as permaculture farm starts to establish itself in the ecosystem. Use and value diversity. This principle addresses one of the major shortcomings of industrial agriculture, that is monoculture crops. It embraces polyculture and makes effective use of diversity of plants to overcome the problems of pests, diseases, and extreme weather. Use edges and value the margin. This principle is all about utilizing every square inch of a permaculture farm so as to maximize its yield. For example, edges of a pond or a dam are good places to grow water-loving plants and vegetables. Fruit hedges and bamboo can be used as fencing around the plot. They act as a windbreaker and a natural barrier to intruders while also generating extra income for the farmer. In our module all about soil, we saw how industrial monoculture practices have depleted topsoil of nutrients and have been responsible for extensive erosion of topsoil. Monoculture. Monoculture is cultivation of a single crop over a wide area over many cycles. Monoculture gives larger yield with few resources. Monoculture also leads to nutrient depletion in soil and requires synthetic fertilizers. Monoculture also destroys soil structure, leading to extensive soil erosion. In adverse conditions such as climate change, pests, and diseases, monoculture is of high risk. Polyculture, when we cultivate multiple mixed crops in the same area and do crop rotation, that process is called polyculture. Polyculture helps stimulate diversity in natural ecosystems. It also helps make use of space, nutrient, water, and energy in a sustainable manner. Polyculture helps preserve soil structure and prevents soil erosion. It gives lower yield compared to monoculture, but plants adapt well to adverse conditions, therefore lower risk. Few examples of traditional polyculture practices. Mesoamerica milpa cycle. In milpa cycle, farmers plant several crops simultaneously. These crops include maize, avocado, varieties of squash, beans, melon, etc. These crops have been known to be nutritionally and environmentally complementary to each other. Bara Anaj polyculture practices in India. It's a mixed farming system in which 12 food grain crops are grown on a single piece of land. Crops include amaranth, beans, finger millet, etc. These polyculture practices protect farmers from crop failures in adverse conditions. These ancient agriculture practices were designed to guarantee some harvest for the farmers, since not all crops planted together will fail simultaneously from pest, disease, or adverse weather.